Good morning, everyone. Okay, welcome and thank you for joining this fourth Surface Ventures webinar. Just before we go any further, I'm just going to check that everyone can see and hear me. So to test this, can you please write where you're joining us from in the chat box on the right-hand side? You should be able to see a chat box appear. Just let us know where you're joining us from today, which part of the world. Excellent. I think great. Thank you very much. It seems like everything's working, which is great. We've got many different places over there. I hope the weather's nice where you are, because it's not nice in the UK today. It's quite miserable and quite cold. But it's that winter. It's that autumn vibe coming up. So oh well. So okay. So I think we're going to begin. My name is Tahid Khan. I'm a VP at Surface Ventures, and I'm your host for today's webinar with Professor Jose Luis Endrino. So Jose is head of the Functional Surfaces and Coatings at Basque Center for Materials, Applications and Nanostructures. So a bit of background, he received his PhD from the University of New Hampshire and worked for companies such as Oerlikon, Balzers, Abengoa Research, Lawrence Berkeley National Labs, and the University of Cranfield. He's published more than 100 scientific articles and has been inventor for more than 20 patent applications in new materials and coatings for solar energy, catalysis and tools. So in terms of the agenda for today's webinar, we're going to start with Jose's presentation and then switch for a few minutes to Nishil Mulder, who's our sponsor from Anton Parr UK, and then we'll come back to Jose for your questions. So we're planning for the session to be about around 60 minutes in total. So the way I like to think about it is it's as you're having a keynote speaker on your screen every month. So just before we move on, I'm just going to say a few words regarding Surface Ventures. We are a non-for-profit organization, and our mission is basically to provide world-class surface engineering education for academia and industry. So what we aim to do is every month we try and bring you a sector-leading speaker to present the current challenges and future trends in surface engineering, like today. What we like to do is we like to learn a little about yourselves, our audience. So we're going to have a bit of a quick poll. We've done this in the past. Like last time, can you please answer the question that should pop up on your screen right about now? The question is, how many Surface Venture webinars have you attended? That's great. So we've got a nice variation of numbers. That's great. Perfect. So thank you for that. Thank you for participating. So what I'd like to do now is hand over to our speaker, Professor Jose Endrino. Jose, over to you.
Thank you very much. Good morning, everyone. Hope you can hear me well. Hope everyone is doing well. After all, we are in 2020. There is this horrible pandemic happening everywhere that has brought nothing good. During confinement, I noticed that many of us actually spent a lot of time watching digital media, videos, movies, and so on. On the other hand, I have some other colleagues that, for example, they spend the confinement time, the lockdown time, writing reviews about COVID, which is also great. But in my case, I was part of the first population of people which I spend a lot of time actually watching videos during lockdown. So I decided at the end of the confinement to actually make kind of a countdown of the 7 top videos and how they were related to the field of surface engineering. So at the beginning, you will think, okay, videos, YouTube videos, and surface engineering. What is the relation? So I try to make an effort to bring those together, and this is what this presentation is mostly about. And I try to correlate them. This presentation is a personal take because I try to correlate them with my own scientific research and how they were related to me. So uh, just briefly about myself, I've been around the block for quite a long time. I did actually my studies in the US, in San Diego State University, bachelor's and master's in mechanical engineering. I did my PhD at the University of New Hampshire. I worked as an R&D project manager at the company Oerlikon Balzers in Liechtenstein. I had a chance to actually participate as a visiting scientist with Professor Andre Anders at the Berkeley Lab. I went back to Spain in 2008 to work for the Material Science Institute of Madrid, worked for another company, renewable energy company called Abengoa, during a few more years, and then I took over a professorship at Cranfield University in the UK, where I was head of Surface Engineering and Nanotechnology Institute. And finally, just a little bit more than a year ago, I joined this vast center of materials, applications, and nanostructures here in Spain, north of Spain, near Bilbao. So let's get started with this countdown. As I told you, the first video that we're gonna be able to watch is about the movie called Knowing. This is a kind of like a geek film from 2009, and it's starred by Oscar winner Nicolas Cage. Nicolas Cage plays in this movie as an MIT professor, John Kessler, and he's kind of like an astronomist professor, a mathematician, and then he gets this mysterious finding of numbers from the future. And the funny thing about this video, or the relation, or how I found it, or what it reminded me of, is basically two things. The outdoor scenes are filmed in a planetarium in Massachusetts, but the indoor scenes, they are actually filmed at the Australian synchrotron. So let's watch the movie and I'll come back.
Hey, John, what happened? Hey! What are you doing, honey?
It's the sun.
There's something I need to check. Get Abby. You're coming with us. Caleb! Hey, John, what happened? Hey! Talk to me. What happened? I've been calling you off the hook ever since I heard about the subway. John.
So you notice Nicolas Cage, he was actually working inside the synchrotron, and he passes right by what is called a synchrotron beam line. And some of the people actually standing there, they are not Hollywood actors. They are real scientists just working over there at the beam line. So what this reminded me of, as you can see, I'm showing some of the examples. I had an opportunity to actually characterize samples in the past using synchrotron X-rays. For example, to use the technique called X-ray absorption. On the left-hand side of the slide, you can see what happens after annealing a platinum dioxide at different temperatures and how this platinum edge actually changes from what is an oxide to a pure platinum. On the right-hand side of this slide, we published another work in which we were able to discover what they are called sodium platinum bronze. If you actually deposit this platinum dioxide over a sodium-containing substrate, what happens? You end up forming some kind of platinum bronze. And this, we were able to discover it first time by using a synchrotron X-ray beam line. So obviously, each one of these examples that I'm giving, they deserve a presentation on their own, and I will be happy to discuss those on a separate presentation. But here I just wanted to give you a taste of, what is the relation between some of these movie themes and some of the work I've done. Okay, so number six actually goes to the video game called Minecraft. This is actually a video game which is played by kids, young people, and adults. It's basically a video game that most people know. You are able to explore different worlds and play with materials and synthesize materials. The nice thing is that once you synthesize these materials, you are able to apply them to these building blocks, and with these building blocks, you can actually build different worlds. What I found nice about this video game, you can actually synthesize things like polymers, ceramics, and metals, and actually use them for different applications, as I just mentioned. What we're going to see in this short tutorial video will be something about the so-called smelter, which is one of the crafting tables where you are able to synthesize materials. So let's play that tutorial video from YouTube. Okay, in this tutorial video, what we see is this crafting table. Okay, it's a tutorial video. What we have in front of us is the smelter. The smelter looks like this, and you can actually see that in this particular smelter there is no power. The power bar is down, so the way down, so it doesn't have any power to be used. And here is where you actually put your precursor materials. Okay, and then on the bottom you will actually have the material that you synthesize. Okay, the video game also comes with a number of standard recipes that you can use, similar to some of the things that we do. There are a number of alloys. I think there are over 80 in the library, and it basically tells you the amount of RF power that is needed in order to synthesize that particular material. Basically, what the smelter is kind of like a melting machine, like a casting machine, but it will tell you very specifically, okay, how many gold or precursor materials you need of a certain type in order to synthesize one particular alloy. The smelter that we have in front of us has a full power bar, so we can actually use it to actually synthesize something. And we just have to pick one from the library. In this case, we're picking the electrical steel, and we need iron, coal, and silicon at certain amounts. And if we are able to find those, when we are exploring the world, we are able to put those in the smelter, apply the right amount of power as long as we have it, and then wait just for a few seconds. We have a progress bar, and at the end, we will be able to have this electric steel synthesized, and we will be able to use it to build things in this exciting video game. Okay. So how is this related to some of the work that we do in surface engineering? Well, in my case, I worked with PVD for a number of years. I keep working on PVD, had a chance to use different equipment in different labs. These are some examples from Erlikon, from the University of New Hampshire, from Berkeley, and so on. And obviously, you can see really the close similarities between this video game and some of the work that we do, because we still have to use some precursor materials in all of these techniques. And plasma-based techniques, obviously, you need a plasma to synthesize it. It's a little bit different, but we also use other power supplies from time to time to prepare isolating coatings. And in some cases, I believe it was in 2010, we came up with a special issue on plasma and ion beam assisted deposited coatings in the Journal of Materials Research, and you can see it on the bottom right. Okay, so number five actually goes to the movie Star Trek, The Voyage Home. What is interesting on this video is actually there is a material science discussion. I want to tell you a little bit about this video because it's a movie back from 1986. And as many movies, it is about saving the Earth from aliens. So it's a common topic in many movies. So in this particular movie, the scientists in there, they actually need to build very large containers, which they need to be transparent in order to allow the sunlight go through them. And they actually needed to transport whales through the space. I want you to listen to this particular theme from this movie, because it's both funny and interesting.
What else would I be working with?
What else?
Professor, your knowledge of engineering is most impressive.
Yes, back home we call him the miracle worker.
Indeed. May I offer you something, gentlemen?
Dr. Nichols, I might be able to offer something to you.
Yeah?
I notice you're still working with polymers.
Still. What else would I be working with?
What else, indeed? I'll put it another way. How thick would a piece of your plexiglass need to be at 60 feet by 10 feet to withstand the pressure of 18,000 cubic feet of water?
Oh, that's easy. 6 inches. We carry stuff that big in stock.
I have noticed. Now just suppose, I were to show you a way to manufacture a wall that would do the same job, but be only 1 inch thick. Would that be worth something to you? Eh?
You're joking.
Perhaps the professor could use your computer.
Please.
Computer? Computer? Hello, computer.
Just use the keyboard.
A keyboard. How quaint.
Transparent aluminum?
That's the ticket, lad.
What's going on behind this theme? You know, they mentioned transparent aluminum. You know, the actors in this movie, they seem surprised, and it says that's your ticket, laddie. You know, he's trying to basically replace polymeric material with something much thinner, made out of what is transparent aluminum. Back in 1985, 1986, when this movie was played, transparent aluminum sounded something like a science fiction material. But things have progressed quite since. And for example, defense departments, the defense sector has actually developed things like aluminum oxynitride, which is actually kind of like an expensive material. But at the same time, we have also progressed a lot, for example, in synthesizing alumina-based coatings. In my particular work, I had the opportunity to actually use, for example, transparent alumina coatings as anti-reflective layers, which are also, you know, both protective and transparent for applications such as concentrated solar power. And obviously, in this concentrated solar power, you reach very high temperatures, and you need to have materials that are stable, that are transparent, that are able to basically be selective. This is what we try to do in concentrated solar power. We try to be selective because we want to allow the maximum amount of sunlight to come into the collector tube, and at the same time, we want to prevent infrared radiation to be emitted. Similarly, in some cases, we developed thermal barrier coatings, or what we call thermal barrier coatings, which basically they are like a stack of layers, and they also were alumina-based. And in this case, optical design is very critical in order for us to optimize those properties for us to have these solar selective coatings. So, I mean, listening to things like transparent aluminum in this old movie was both funny and interesting. Okay, number 4, I think this is one that everybody will love. It's a funny sitcom from the US. It's called The Big Bang Theory. Everybody knows this sitcom is extremely funny. The main character in this sitcom is Sheldon Cooper. He's kind of like this annoying character. Everybody is always having fun with him, or having interesting discussions with him. And in the scene that we are going to watch now, basically, Sheldon visits the lab of Howard Wolrich, his friend. And Howard is from a different background. He's an aerospace engineer. So I wanted to listen to this interesting conversation about material selection. Let's play it.
It's a small brown paper bag, Ma. I'm looking at it right now. Why would I make that up? There's no ding-dong in it. How are 2 ding-dongs tomorrow going to help me today?
So, this is engineering, huh?
I'll talk to you later. To engineering, where the noble, semi-skilled laborers execute the vision of those who think and dream. Hello, Oompa Loompas of science. Sheldon, what are you doing here? I just came by to say hello. I've been in this lab for 3 years. You've never come by to say hello. Well, up until now, I've had better things to do. So, what are we making today? A small payload support structure for a European science experimental package that's going up on the next space shuttle. Really? How does it work? When this is done, it will be attached to the payload bay, and the sensor apparatus will rest on it. Uh-huh. So it's a shelf. No, you don't understand. During acceleration, it needs to stay perfectly level and provide... Yeah, okay, it's a shelf. I notice you're using titanium. Did you give any consideration to carbon nanotubes? They're lighter, cheaper, and have twice the tensile strength. Sheldon, there's a diploma in my office that says I have a master's in engineering. And you also have a note from your mother that says, I love you, boobala. But neither of those is a cogent argument for titanium over nanotubes. Sheldon? Yes? Go away. Did Leonard tell you to say that? No, I thought of it all by myself. Huh. It can't be a coincidence.
Basically, there is this conversation between Sheldon and Golovich, and basically he says, okay, have you given any consideration to carbon nanotubes? They are lighter, cheaper, and they have twice the tensile strength of titanium. Okay, so good point, Sheldon, I guess. Well, this kind of reminds me some of the work we published earlier this year, in which we were developing some coatings. These coatings, basically, they were based on calcium phosphates that they were extracted from directly from some fish in Colombia, and we needed to improve the mechanical properties of those coatings. And one way, the way we were successful was basically by introducing different loads of carbon nanotubes into the coating. And you can see on the bottom right, actually, these addition curves from different coatings with containing different amount of nanotubes. And as we increase the number of nanotubes, the addition strength increased. I think it is always funny, to realize that, there are actually examples in this kind of movie sitcoms and so on that sometimes relate a lot to your work. Let's move on to the next one. Okay, number 3 goes to the movie Signs. It's a movie starred by Mel Gibson and Joaquin Phoenix. It's a movie from 2002, and it's kind of like an American horror movie in which basically there is a family living in a farm, and then they start seeing these crop circles right in their backyard. Okay, and then they start thinking about, okay, this could be related to some kind of alien invasion. And obviously this kind of sign circles, they start happening all around the world. I really encourage you to watch the movie. It's a good one. It's a horror movie in this case. So let's play it. And I want you to pay special attention to the tinfoil hats that they are used. In this case, this is basically the trailer of this movie. Okay, so let's play it.
Who can make geometric shapes the size of a football field?
What kind of machine can bend a stack of corn over without breaking it?
Can't be by hand, it's too perfect.
So the aliens can't read our minds?
Oh.
Some animals around the county have been acting funny. Some of them violent. It's almost like they act when they smell a predator around.
Amman, Nairobi, Bangalore, and Jerusalem as the
Same shows on every station.
Every station.
It is the 18th reported crop site in that country in the last 72 hours.
I'm a little scared. All this stuff on TV. Joe Gills was in here talking about the end of the world.
By some sun saying so that the aliens can read our minds. They are wearing these silly tinfoil hats, which basically they are help in the movie, they help to prevent or block these waves or the aliens to reading in our minds, right? I mean, it's an interesting story at least. So some recent work that I have done, well, I mean, if we think about foils, membranes, and laminates as the ultimate expression of a coating or a coating without a substrate, I think obviously we can open up a number of applications that are very interesting to us. In my case, I found myself collaborating with some colleagues from the Institute of Material Science in Madrid and some colleagues from an institute in Moscow, working in these multi-layer laminates that actually they help to reduce the thermal conductivity quite a bit. And the way this is achieved basically is by by having both noble metal layers combined with ceramic layers. For example, in this case, it was silver, titanium, aluminum, nitride layers, and by doing so, we actually help reduce the thermal conductivity of the titanium, aluminum, nitride. One will think, okay, by having silver layers, we will actually have an increased thermal conductivity, but actually it is the opposite, because what we are doing is to actually introduce ways to actually block and reduce the transmission of phonons transmitting across some of these layers. So interesting, in the movie, of course, we are talking about blocking some waves from some aliens. In this work, we're talking about, okay, waves from phonons, okay? Let's go to the next one, okay? Allow me to give number 2, the position 2, to my colleagues at Cranfield University, Cranfield Manufacturing. We had an opportunity to work with a group of 4 very successful MSc students, and these MSc students, they had to develop what is called a group project. In this group project was actually co-supervised by colleagues, by a colleague in Cranfield, Luis Isen, and my colleague Su Impi, as well as myself, and we had also the support of the company CIFCO, which is a branch electroplating company. And what this small group of students did, and successfully did, even if they didn't have any software background, they developed a virtual reality software. From our point of view, I think this is the first time virtual reality is introduced significantly as a teaching aid in surface engineering. And what they did was something unique. Basically, they simulated using virtual reality, or they created the program using virtual reality of what is the replacement of the cadmium coating on the landing gear train. So what you will see in this video is actually a video of one of the students, Francisco. Francisco is using the virtual reality kit in order for him to actually replace the cadmium coating following a number of steps. So in this training guide, basically, he will start first by wearing the PPE, looking at some calculations in order for him to adjust and get the right amount of voltage for electrode deposition. And then he will actually follow a number of steps in order for him to replace the cadmium coating, which is critical as a maintenance thing that has to be done from time to time in landing gear trains. So let's watch this movie and I will come back. video. It was again. I want to congratulate one more my students there because they were very successful. For us, to the best of our knowledge, is the first time virtual reality is used as a learning aid in surface engineering, and they developed this tool which is actually available for people to actually learn how to do brush plating, especially brush plating in landing gear trains. So it's actually a complete program that actually trains people to do something practical. I don't have time to actually explain the whole brush plating process. I believe is well known by now. What I want to mention is just a tiny little bit about what can you do with brush plating. In some PhD work that we carried out at the University of Cranfield, we were able to actually use the brush plating technique in order for us to do some metal matrix composite coatings. And the objective of this work was actually to find hard chrome replacements. Some of the scientific work we have reported in different journals. For example, in one case, we actually developed like what is called a structure zone diagram that basically describes what happens with the particle incorporation when something is nickel brush plated. And at the same time, on the right-hand side, you can see another study that we published in which we were able to include and tungsten carbide particles into the mixture and actually be able to deliver them through the brush plating technique. So I encourage you to read that work. Okay, so I think we reached the top of the list. Number one, I think is an epic one. You may recognize the character there. Is actually Daniel Radcliffe. Daniel Radcliffe is you may recognize him because he's the actor the actor from the Harry Potter movies. Obviously, he has grown up quite a bit. And in this movie, I just want you to watch a scene that I found particularly epic. Listen, just it's very brief, short, and basically listen to the discussion about the materials and the decorative coatings that they used for this movie. Let's play it.
Send this to my Gmail.
It's funny you're watching.
Oh, God. Look, Richard, he's trying to expand Schism. He's like building into a global franchise. Can you actually just like send this to my Gmail?
It's funny you're watching.
Oh, God.
Oh! Nice AA12.
These things?
Yes.
Yeah, I shelled out for the deep block PVD coating, but now I kind of regret not going with the UCP style camo.
Oh no, you're crazy. She's crazy. You totally own it. Seriously.
Thank you. Yeah, you know your weapons.
Yeah. Shits in the head is life.
Well, I better,
Right, yeah. Do you think it's
So the conversation goes a little bit like this. Say 12s, it says these things. I checked out for the deep black PVD coating, but now I sort of regret not going for the UCP style camo. I know you're crazy. She's crazy. You totally own it. Thanks. So the funny thing for me was, when I heard about this deep black PVD coating, it was interesting how they referred to diamond-like carbon. For us working in the field of diamond-like carbon, obviously it's always interesting to listen to these words and to believe that society can actually understand what we mean from time to time when we mention things like diamond-like carbon. I had the opportunity to work with different types of diamond-like carbon, whether they are deposited by CVD, PVD, in some cases filtered cathodic arc, and so on. Last year we published some work in one of the scientific article. It referred to the deposition of diamond-like carbons and diamond-like carbon that they contain a certain amount of lubricants. In this case, tungsten disulfide was selected for the machining of aluminum alloys. It was actually aluminum alloys that had a high amount of silicon content, so they were tough to machine. The tests were run dry, and we were successful to actually machine those when they had a certain amount of tungsten disulfide. And I also encourage you, obviously, to read that work. Let me move on to the next slide. Basically, in summary, these are my top 7. The top 7 I came up during confinement, during lockdown. Number 7 went to the movie Knowing, in which basically we were able to to see during that movie Nicolas Cage in a synchrotron facility. Then I presented to you the video game Minecraft, in which we use actually a crafting table, a smelter, in order to synthesize different alloys, metallic alloys. The movie Star Trek was interesting because basically it dealt with transparent aluminium, and I related this to some of my work in concentrated solar power. The Big Bang Theory was nice to hear Sheldon Cooper talking about the differences between carbon nanotubes and titanium, and how this related maybe to some coatings in which we are able to incorporate carbon nanotubes to make them better. Then the movie Science, in which they use these tinfoil hats as barriers, and I related this to some of the multi-layer work that has been done in order to create layers with very extremely low thermal conductivities. I presented to you this brush plating video from my colleagues at Cranfield University, in which the students themselves, they develop a virtual reality program, and this virtual reality program is like a training aid, training tool that you can use in order to repair and fix landing gear planes and replace the cadmium coating there. And finally, and I think the top one, I think it's an epic one, is from the movie Guns Akimbo, where they refer to this diamond-like carbon coating. It was nice, really nice to see that in such an action-packed movie. Okay, so this finishes my presentation. I obviously encourage you to stick around because Anton Parr has also a very interesting presentation. Anton Parr always introduces innovation, and I always listen to something interesting in their presentation. So I think it's time for them to join.
Really interesting talk. So what we're going to do is we're going to hand over to Nishal from Anton Parr, and then we'll take questions for Jose, and if there's anything for Nishal too. Feel free to use the chat box, everyone, to put in your questions. So I'll hand over to Nishal.
Hello, everybody. Thank you very much for joining this excellent webinar. I must thank Surface Ventures and Jose for creating this webinar and the opportunity to actually learn a little bit more about service engineering and surface characterization. So my name is Nishal Malde. I'm a product manager at Anton Parr here in the UK and Ireland. And I'm going to just briefly go through some of the solutions that are available for characterizing surface material properties that you know have come across through the discussion with Jose's presented this morning. So just moving on to the next slide. For some of you who may not be aware of Anton Parr have got a very rich history in actual scientific instrumentation since back down to 1922. So we're coming up to being a nearly 100-year-old company. It started off as being a precision locksmith company, and by 1957 we launched the first scientific instrument, and that was the crack key small angle X-ray scattering camera, or what is now known as SAX. And then as we move through the generations and the years, we're now in 2020, and we are a fully established instrumentation manufacturer. We're global. We're about over 3,000 employees globally. We have around about 35 offices worldwide, many in your locations, which I can see from the attendees. The key point is that Anton Parr are actually founded as a charitable foundation. So we don't have any actual shareholders or stakeholders. And that means that we can actually invest every year 20% of our revenue back into our research and development to develop scientific instruments that are needed by users of or people working in materials characterizations like yourselves, and a lot of that development comes from discussions and interest and webinars of this nature. Moving on to the next slide. So we cater for a number of different applications, whether you're working on coatings, thin films, maybe working on semiconductor materials like wafers, polymers, fibers, membranes, glass, medical devices, medical materials, biological systems. we cover a wide range of applications, and that kind of encompasses what Jose's presentation kind of revealed, that when you look at surface materials or surface characterization or surface properties, it does cover a wide multitude of material technologies. It's not just a single element anymore. And the type of properties that we're able to kind of measure with the techniques that we have is everything from mechanical surface properties, things like hardness, elastomodulus, stress strain, fracture, looking at frictional properties, wear properties, porosity, surface roughness, nanostructure, coating adhesion, coating thicknesses. These are the kind of properties that we actually can determine in a quantifiable, reliable and reproducible manner with our techniques and instruments that we have in our portfolio. Just to give you a quick slide to tell you the type of solutions that we can present is everything from, as I said to you, indentation testers all the way through to the small angle X-ray scattering systems, basically what you see in the synchrotrons into your lab scale availability. I'm going to stop there now, and I'm going to introduce a very short video that probably presents what I've just said in the video itself. So I'm going to hand over and let you watch a very short video.
Thank you very much, Nisho and Anton Parr. On your screen, you should see some of Anton Parr's brochures for some of their equipment and some of the characterization techniques that they do. So what we'll do now is we'll take some questions from the audience. I'm sure it's been a very thorough and interesting talk. There's a few questions, so let's start off. First question is, why is DLC better than graphite coatings?
Okay,
Jose?
yes. Well, that's a good question. For decorative applications, I mean, if there is no mechanical applications involved, DLC coating, we have to distinguish between DLC coating and amorphous carbon coating. When we deposit this type of carbon, pure carbon coatings with PVD techniques, obviously there are the ones that they are so-called amorphous carbon. Those ones, they actually have lower amounts of sp3 bonding, so the properties will be closer to graphite. If we just think about pure graphite coatings, they will not basically have the sufficient mechanical stability for them to work well in applications such as the one that we saw in the movie, which is basically decorative coatings that they can be used for weapons and things like that. So yes, obviously there are big differences between DLC and pure graphite coatings.
Excellent. The next question, well, I hope that answered the question. The next one is, what aluminium parts are being machined by DLC coated tools. What is the standard cutting tool material for this application?
Yeah, well, in the work that I showed, actually, we were working on top of a titanium diboride coating because it's a very hard coating. It's a natural hard material, titanium diboride, and what we were trying to improve is the frictional properties, the tribological properties during machining when we added some coatings. What happens is in that particular work, we were distinguishing between DLC coatings and DLC coatings that they also incorporate a lubricant phase. And in those cases, we are able to find, let's say, some improvements when we use this DLC coating, including tungsten disulfide phase. The question about what kind of parts are machined, it depends. I mean, obviously, many parts are machined, made of aluminium for multiple applications. In the case of the particular material that we were machining in this study, it refers to high silicon containing aluminium. And in those cases, we can think about cases, pistons in an automotive car, things like that, things that they require a certain amount of mechanical strength. And in those cases, yes, we will use this kind of high silicon containing aluminium alloys.
Excellent. Another question, any correlation between surface textures and DLC?
Surface textures and DLC, well, this is something, this could be a good investigation to do jointly with Anton Park, because obviously they have AFM equipment, they have tribological equipment. We can measure many things on the surface straight with them. So I think Anton Park would be a very good partner for that. Yes, I mean, in some cases, the surface topography of the DLC can be important for some applications. In general, DLC coatings deposited with PVD, they will be flat. But obviously, if you use a technique such as filter cathodic arc, you may end up having some microparticles in the surface. So in those cases, if you really need to have a flat surface, you will need to remove the particles using brushes and other types of approaches.
Excellent. Next question. What is likely to be the next big development in surfaces and coatings?
The next big
development in surfaces and coatings.
The next big development in surfaces and coatings. Well, yes, I mean, if I knew that, if only we knew that, right? Yeah, it's a difficult question, but I think this is the kind of forum where we should actually have a live session with maybe multiple partners. I think there is still potential for DLC to do much more investigation on DLC. I don't think we have found all the applications for diamond-like carbon. Nitrides are also interesting. Some people are being successful with oxonitrides. And obviously, graphene is a big push for all of us, and graphene-related materials. There is ongoing novel work that incorporates this kind of 2D layer materials into matrices such as DLC. So there is a wide number of opportunities there, but it's very difficult for me to say. And I think we need a number of people, you know, to give their opinion about this.
Sure. What type of indenter are you using for your scratch test, and what magnitude of loads are being used?
Well, if this refers to the study that was published, I will have to check it. But this was basically a scratch test that was used just to check the addition. And basically, you know, we just needed to be sensitive enough to make sure that, you know, we are able to detect, okay, when the coatings start to fail and be able to compare among different coatings. So, but obviously, you know, there are other tools, the other indenters and other micro scratch testers that, you know, they will give you even more, much wider information than the one I was using.
Sure, and I think it's a follow-up question from that one. What types of DLC are being used? Hydrogenated?
My particular work has been focused on non-hydrogenated DLC. This is because, yes, I mean, that's the advantage of PVD deposited DLC coatings. You end up with non-hydrogenated coatings, which are supposed to be a little bit less brittle than the other ones. So it is kind of a little bit of an advantage, but obviously the hydrogenated DLC also have other kind of applications. You can have, in some cases, more conformal coatings if you use hydrogenated coatings.
Sure. Another question: how far the DLC coated being? Sorry, how far the DLC being coated over the UHM WPE implants?
Yeah, well,
I think
I guess this is again another question for me. I have done some work in the past, depositing DLC on ultra high molecular weight polyethylene. I mean, it's basically I need to give a long explanation to this one. But basically, DLC is a very hard coating. We all agree on that. In some cases, this coating, in terms of implants, it is deposited on the metallic part. But in some cases, some of the diseases that happen with implants, they happen because of the wear down of the polymer. That means that in some cases, it would be actually useful to have the DLC coating on the ultra high molecular weight polyethylene. So yes, this is something interesting. This is something that has been done. How far the DLC being coated over? I believe this relates to how thick will the DLC have to be. In those particular applications, you don't want to have a coating too thick.
one of the questions, I think I've got a little bit of a follow-up question on it. It's a light one. Jose, which one of the clips was your favorite film? And I've got a bit of a follow-up to that.
Okay, sorry, maybe I didn't make it clear, but it was kind of like a countdown. So I went from 7 to 1. So my favorite was the number 1. It was the one from Guns Akimbo movie. For me, was my favorite because it relates to DLC. But it is a personal take. I guess somebody else can come up with their own list. They don't count down and they don't top 7. You know, so it's a personal point of view.
And I would ask, would you say there's any materials or surface engineering challenges in the Bond films?
I think there are material challenges everywhere. You know, if we pay close attention, you know, if we really put enough attention, I think we will find material challenges everywhere and things related to coatings that appear in our daily life more often than what we think. So yes, I mean, in those cases, I try to bring in the most obvious ones, but they are not the only ones.
Sure. And I think a question is, DLC coatings on titanium have failed in vivo bioimplant applications. Any comment on that?
Yeah, I agree. There is a study published on that long ago, and actually, yes, in kind of the animal models that they have been used, sometimes the DLC coatings they have failed, and they have cost us to have, let's say, a bad because of a bad properties, bad addition, and so on. The animal model was not successful. We see this now with the COVID. You know, I mean, just because something works in the lab and something works in phase 1, you know, a vaccine can be very good in phase 1, but it needs to go through all these different phases. So, you know, sometimes even if we kind of carry out any kind of biotribological test and other type of test, we can never be certain until we do the in vivo tests. So I do agree with that.
Excellent. And that's all
it
the
also
questions
says these
at the
were
moment,
on humans. Okay, these were on humans. Yes, that's true.
Yep.
But okay, not my fault. I guess somebody else, some medical agency approved a DLC coating for implants, and for whatever reason they failed. And if they did so, basically the medical company will be sued by the people that were actually affected by this failure. So it is our responsibility to do our research as good as we can, so that, you know, when we reach those stages, we go there with the best possible coatings.
Of course. So at that point, I'll start to wrap up. So I want to thank everyone for your questions. Thank you, Jose, for this engaging talk. Thank you for sharing. It's really appreciated. Yes. We hope the audience enjoyed that.
Thank you for listening.
I want to thank Anton Parr and Nishal for supporting this webinar. Just a reminder for everyone, you'll receive a link to the recorded video automatically from the platform Demio. Hopefully we'll be organizing the next webinar towards the end of October, so stay tuned for that. So on that note, we hope to see you next time. We hope you enjoyed it. But for now, thank you for joining, and enjoy the rest of your day.